Here it is again, the fabulous power plant on which all life on Earth depends. And here, in Andalusia, bathed in solar radiation for 3,000 hours per year, is the Plataforma Solar de Almeria, or P.S.A. This is a unique European test facility dedicated to creating practical solar systems which can deliver clean energy, clean water, and clean chemical processing. In the quest for effective, commercially viable applications of solar energy, the P.S.A. has a secret weapon: concentration. Already well known are the possibilities of concentrating solar energy using focusing devices such as parabolic troughs, parabolic dishes, and power towers. But to turn these possibilities into commercial technologies demands the committed input of a multidisciplinary team of highly qualified experts, as well as state-of-the-art testing facilities. The chance to pool human as well as physical resources led the Spanish and German governments to develop the P.S.A., a place where scientists and engineers from the Spanish Center for Energy, Environmental and Technological Research, CIEMAT, work alongside colleagues from DLR, the German Aerospace Center, as a seamless team. To appreciate the success of this endeavor, it is only necessary to look at some of the team's achievements. We'll start with power towers, where solar radiation is focused by heliostats onto a central receiver at the top of a tower. Solar power towers depend on two critical components: the heliostat and the solar receiver. As a result of a program at the P.S.A. to develop low-cost, large-area heliostats, Spain and Germany have dramatically reduced costs from 300 euros per square meter to 140 euros per square meter without compromising performance, and are now world leaders in this technology. Meanwhile, an entirely new type of solar receiver has been developed and tested at the P.S.A. The volumetric receiver. This receiver uses air as a heat transfer medium and is designed for safety and simplicity. It will be instrumental in the future solar powering of gas turbines and combined cycles. Parabolic troughs were the first solar concentrating technology to be used at commercial scale. These trough systems still use an intermediate heat transfer fluid to bring the absorbed solar energy from the solar field to the power block where it is used to produce turbine steam. The main goal of the DEES project at the Plataforma is the elimination of this intermediate step, generating steam directly in the absorber tubes of the solar collectors. The resulting increased efficiency and other planned optimization will reduce the cost of electricity produced in parabolic trough plants by 26%. Parabolic dishes can deliver the highest levels of concentration possible. Solar-powered dish Stirling systems have been successfully operated at the P.S.A. for more than 35,000 hours. Cost reduction and unmanned remote operation are now the new development targets. So far, we have mentioned only one end product, electricity, but concentrated solar energy can be usefully deployed in other ways. A significant thermal application is in desalination. A project operated jointly at the P.S.A. demonstrated the technical feasibility and reliability of coupling a multi-effect distillation plant to a parabolic trough solar field. This plant supplies water needed for the P.S.A. pilot plants. The P.S.A. also plays a role in space systems development, providing an excellent European test facility which can simulate the thermal conditions experienced by space vehicles entering the Earth's and other planetary atmospheres. Meanwhile, scientists at the P.S.A. have come up with a solar answer to water and air contamination, a serious problem associated with industrial and agricultural activity. Photocatalytic systems have been developed which use ultraviolet radiation to destroy some of the most difficult, persistent organic pollutants in water or gas phase. Technology developments at the P.S.A. have led to the commercial demonstration of this technology by a European consortium. But technology is not at the center of the P.S.A.'s operations. That position is reserved for people. For education, training, and dissemination are an integral part of the P.S.A. program. Each year, 70 to 80 students, teaching staff, and researchers from all over Europe are hosted at the Plataforma, often supported by an EC mobility or research program. In addition, through participation in the International Energy Agency's Solar P.S.A. program, the P.S.A. has developed strong links with the world's other top R&D facilities in the field, and with potential technology supplier and user outside Europe. As the 21st century opens, the full-scale deployment of solar thermal power technologies is rapidly becoming a reality, driven by concerns with global warming and oil price instability. No single organization, or even country, has all the answers. The consortia bidding for projects underway in Spain, Greece, Egypt, India, and elsewhere are characterized by their global nature. But you can be sure that Spanish and German companies are well represented. P.S.A. team members, like the companies who test equipment at the site, are now accustomed to finding their way through different customs, languages, and administrative systems. Yes, they have learned to concentrate solar energy. But they have gone one step further and have learned how to concentrate knowledge.